So today we're going to take a look at the reciprocal function and its graph and its many interesting properties. So the reciprocal function is the function defined by the expression 1 over x, where x is the independent variable. So let's take a look at what this does. First of all, the domain of the reciprocal function. Well, you can plug in almost anything for x here, except 0. When x is 0, 1 over x is undefined. So the reciprocal function has domain consisting of every real number except for 0. So there's that written in interval notation. In kind of a bastardized set notation, we have x in the real numbers such that x is not the value 0. So what does this function look like? Let's think about what it does for positive values of x. For example, when x is 1. When x is 1, f of x is 1 over x, f of x is 1 over 1, which is 1. Let's try some others. When x is 2, then f of x is 1 over 2, or a half. When x is 4, f of x is 1 over 4, or a fourth. So we see that we have this point 1, 1, and then 2, a half, 4, a fourth, and so forth and so on. So as we get larger and larger over here on the right, our graph is going to get closer and closer to 0, but it'll never reach it. Well, let's see what it's doing over here for positive values to the left of 1. So we're looking at small values of x. Say a half. When x is a half, we have f of a half is 1 over a half, but you know that simplifies to 2. So when we plug in a half for x, we get 2. Similarly, if we plug in a fourth for x, we're going to get 1 over 1/4, but that just simplifies to 4. So f of a fourth is 4. So we go and we get values 1/2, 2, 1/4, 4, and so forth. So as we get closer to 0 coming from the left, the positive direction, our values for f are getting higher and higher. But we're never actually going to hit a maximum value, and we can plug in values closer and closer and closer to 0, but we're never actually going to be able to plug in 0 itself. So what this looks like is like so. It's getting higher and higher and higher as we get closer and closer to 0. Comes down here, goes through the point 1, 1. And then it starts to flatten out and gets closer and closer to 0 the farther out we go. Something similar is going to happen if we look at values for x in the negative part of the domain, so to the left. If we plug in, say, for example, -1, we get 1 over -1, which is just -1. If we plug in -2, we get 1 over -2, which is -1/2. If we plug in -4, we get 1 over -4, which is -1/4. If we plug in -1/2, we get -2. If we plug in -1/4, we get -4. So you see we've got a mirror image pattern over here to the left, where we've got -1, -1, -2, -1/2, -4, -1/4, and then -1/2, 2, -1/4, 4. So what we get is something that, as we get more and more and more negative, gets closer and closer to 0, kind of comes up here through -1, -1, and then as we get closer and closer to 0, we get more and more and more negative. So this is what the graph looks like for the reciprocal function. You can see pretty clearly from looking at this graph that the domain and the range are the same. So the range is also every real number except for 0. There's no x or y intercepts in the reciprocal function. It doesn't cross either the x or the y axis. There's no maximum or minimum values, relative or absolute. It is decreasing for negative values of x and for positive values of x. It's an odd function. And if you recall, what odd means is that for any value in the domain, if you plug in its opposite, you get the opposite of the function applied to the original value. It has asymptotes, and an asymptote is a line where the function is getting closer and closer and closer to that line, but never reaching it. So we see we have asymptotes here. We have a vertical asymptote, which is the line x equals 0, which is the y-axis, and we have a horizontal asymptote, which is the line y equals 0, or the x-axis. And you see when you look at the graph that it is in fact getting closer and closer and closer to each of those axes, but it will never actually reach them. Another interesting fact about the reciprocal function that we'll see later in the term is that the reciprocal function is an example of a function that is its own inverse function. So now we know some interesting facts about the reciprocal function, and we have the shape of its graph, so we can go ahead and add that function to our library.